Lesson 2.4 Algebraic Reasoning. When you solve an algebraic equation, use properties of algebra to justify each step. Segment length and angle measure are real numbers, just like variables. So you can solve equations from geometry using properties from algebra to justify each step. Here are properties of algebra, properties of equality. The reflexive is A equals A. That's like saying 2 equals 2. It's the exact same thing on each side of the equal sign. Symmetry, A equals B, then B equals A. It's like saying 2 is X, therefore X is 2. Transitive, if A equals B and B equals C, then A equals C. The middle part's the same, so the first and last have to be equal. Adding and subtracting, notice this is adding or subtracting the same thing to both sides of the equation. So it's like when you're solving equations and you add 2 to both sides. If you're just trying to combine things on one side, that would be simplify. Multiply and divide is the same thing. It's doing the same thing to both sides. We're doing the same thing to both sides of the equation. Substitution, if A equals B, then A may be replaced by B in any equation or expression. So if two things are exactly the same, you can replace one with the other anywhere. And the distributive property. A times B plus C is A times B plus A times C. Name the property of equality the statement illustrates. If measure of angle 6 equals measure of angle 7, then measure of angle 7 equals measure of angle 6. What do you think it is? Notice the sides of the equation have switched sides. So yes, that is symmetric. How about if JK equals KL and KL equals 12, then JK equals 12. Notice there's 3 parts and the middle are the same, so that makes it, that's right, transitive. How about measure of angle W equals measure of angle W? Very good. It's exactly the same on both sides, so it is reflexive. Let's solve this equation and write a reason for each step. Maybe a first thing is that it's given. And now we're going to, distributing looks like it should work. So it would be 21 minus 3x. So what did we do? We distribute. Here we can combine these, and so now it's not adding or subtracting because I didn't do it to both sides. I just combined things on one side. So that is simplify. Then we can subtract 21. Now we did subtract this from both sides, so that would be subtraction. And then divide by the 11. So we divided both sides by 11. What did we do? We divide. Let's try another. All right, again, the problem is given. If I want to solve it for b, I could get rid of the half, so I'll multiply both sides by 2. So what I do, I multiplied. And then, let's see, to get the b, it's b times h. We'll do the opposite, get rid of h. So what do we do to both sides? We divided. But the final answer should be B equals 2a over h. If I flip the order, if I flip the two sides around, that is symmetric. All right, let's solve this equation. Actually, it's showing this angles are equal from the picture. So we're given measure of angle ABD, that's this combined, equals measure of angle CBE, that's these two. So we start off by writing what they gave us, and we say that was given. But then we look at this and we say, what? Well, notice angle ABD is made up of angle 1 and 2. And measure of angle CBE is made up of 2 and 3. Both of those, oh, what was that? That was small angle plus small angle equals the big angle. So that is the angle addition postulate. Now, ABD is the same as 1 and 2. So I could take this equation but replace measure of angle ABD with measure of angle 1 plus measure of angle 2. Likewise, measure of angle CBE is measure of angle 2 plus measure of angle 3. So I've replaced things with what they equal. That is substitution. Now I want just measure of angle 1 and measure of angle 3. I don't want the measure of angle 2. Conveniently, it's on both sides, so we could just subtract it. What did we do? We subtracted. And notice, we're left with what we were trying to get. Measure of angle 1 equals measure of angle 3.